Today is dust collection day for the CNC machine. So this is a 644 pants branch, and it looks like or pants Y. It looks like a pair of pants, so they call it a pants Y. This has got two 4-inch ports on the bottom, one 6-inch on top, or hose adapters, I should say. And I'm taking inspiration from Frank Howarth for this. This is just temporarily secured up there with a bungee, just so I can kind of figure stuff out. I have to still figure out how that's going to be attached. But I'll have a dust shoe on the spindle with two 4-inch ports on it. So the two 4-inch ports will come up into that. And then a 6-inch hose, this hose over here, will attach to that. This 6-inch hose is bungeed to the rafters temporarily until I figure out how I need to make adjustments after it's all hooked up. And that goes into another branch of the actual dust collection piping. And I put the blast gate way over here so that as I'm switching these blast gates for other stuff, it's conveniently located right there. I can switch them all in the same spot rather than walking all the way over to the CNC machine. It is way up high. I can't reach that. So I have a stick with a magnet and tape wrapped around the magnet so it doesn't shatter the magnet. Very easily open and close that blast gate. Super simple. But today, I'm going to tell you guys how I went through the process of making a dust shoe for this and prototyping it with various versions. I made a lot of changes throughout the prototyping process, so I'm just going to gloss over what I did. So this is the first one out of 1/4-inch plywood, just to get something physical in place so I could look at something and physically see some changes. So I wanted to verify that I had enough space back here on the back side of the spindle before it interferes with the Z-axis. I wanted to make sure that these holes were the correct size, which they're not on this one. My plan was to mount these from the bottom. They're not the right size, so I need to make an adjustment there. And then of course the size of the spindle. This fit on the spindle, but it was super tight. So I need to loosen this up a little bit, and the way I wanted to clamp it to the spindle is by cutting a relief right here with the bandsaw, and then a bolt or a screw going perpendicular to that so that I could tighten it down and clamp it, reducing this diameter onto the spindle. So I learned a little bit from this one on to version number 2. Version number 2 is very similar, but 3/4-inch plywood. Made a couple changes to reduce the size and also increase a little bit of mass around the magnets here, just because I thought there wasn't much material here. So I made that change. These holes are still not the right size, but I figured if I'm going to use 3/4-inch plywood for the top plate, well, that's going to leave me enough material to mount directly to the top of it with these ports. So this flange has mounting holes. That'll be super easy. So at that point, these don't matter anymore. My adjustment to this made it too loose. So with a clamp right here, I could just barely put enough pressure to get this to tighten up. So I needed to go in between my adjustment there as far as getting that a little bit larger. These holes for the magnets were too tight. I could not get a magnet in here, so I needed to make that adjustment. And I figured, let's get the dust hoses as close to the spindle as possible. So I made a note to move this in by 1/4 inch. The rest of it, seemed okay. So version 2 done. Version 3, and this one, the diameter for the spindle was perfect with a regular washer head screw. This is actually a 2.5-inch long pocket hole screw with an added washer down below it, just to prevent this part of the plywood from splitting. And I kind of drilled it off angle after the cut was made, so it wandered on me a little bit as I tightened it down. But this screw tightened it down perfect. It was very, very tight. Now, I'm a little hesitant to use a screw here into plywood because if you're going to adjust something, then you want to have basically. If this is removed a couple of times, then you lose a little bit of precision in your hole with screws versus a bolt that would be a little bit more longer lasting. Then again, how often am I going to remove this? Very rarely, and if it is plywood, I can always cut another if this ends up not working. But in this case, it clamped down just fine. The holes for the magnets are perfect, and I think, yeah, right here I actually still have a magnet in place. So that works out just well. These holes are counter bores, so I can push the magnet down so that the bottom surface of the magnet is 1/4 of an inch away from the bottom surface of this plate, so that a steel dowel can go in there 1/4 of an inch. The dowel will hold the bottom plate to this surface, and also the steel dowels sticking into this plate will stop this from shifting around. So that's a registration, the method of registering these two together. Let's see, so with this done, I decided to figure out a little bit of work on the bottom plate for the brushes. So let's talk about brushes. The first one I ordered was this one. It is too short. I bought this based upon a recommendation in an online forum without taking into consideration the changes of their design versus my design. So I just blindly ordered it. It's too short. It's got a rigid back here, so it's metal just folded over. But the length won't work. So I ordered the second one. This one is much longer. It's 3 inches, but as you can see, it is ridiculously flimsy, way too flimsy for dust collection. I put this around one of my 4-inch flexible hoses that I have here in the shop, and all of these brushes just folded over with no problem whatsoever. So while this is a rigid back, it would bend around all of this shape just fine. It's too flimsy, wouldn't work. So version number 3 that I ordered, or brush number 3. This is much stiffer, does not deflect much at all with the dust collection, which I like, and it has a rigid back. I didn't know how the rigid back would work, so I figured if this is the one that I'm going to try, I might as well cut out a quick bending form. So this is the size that I need, the interior size that I need this to bend around. So I could clamp it, bend it around, and will that work? Well, kinda. I don't know if you can see, but all right, there you can see. So it does bend a little bit around here, but due to this basically being a triangle profile of just metal folded over onto both sides of these brushes, it bended around, but it also bent downward and upward. I could not get this to bend cleanly. So all of that to say, this is the brush that I'm using, but I'm not going to use a radius to go around the port. Instead, I'm just going to make a rectangle with this. So version number 4 of the prototype, which I think is the one that I'll actually bolt to the machine and use, or screw to the machine and use. This is the top plate. Let's get this out of the way. This is number 4. This is the top plate. Too many pieces of plywood around now. I have not cut the slot yet for the spindle. I wanted to make sure all the dimensions worked out. Now you'll notice I went down to 4 magnets instead of 8 because I figured that these are the magnets that I'm going to be using, and these are the steel pins that I will be using. This is plenty strong enough. This has a lot of pull with just one. Now I understand if you have multiple magnets stacked up like this, your pull is going to be greater. But that also tells me something. With this just having one magnet on it, it is kind of pretty easy to pull off. I think just one magnet and 4 of these will still be fine. But if it's not strong enough, then I know that I could always stack more magnets. There's plenty enough room inside these counterbores to stack multiple magnets and get a lot more pull. So steel pins, they will go in the bottom plate, referencing off or connecting to these magnets here. So I switched from 8 down to 4, and I moved them in a little bit closer. So this is, like I said, the top plate, not much going on, kind of a rectangular shape. This is the bottom plate, and the front side is facing you on the camera. So the bottom plate will have a handle on it, so I can pull down on the front, kind of suitcase looking. So I'll pull this down to pull the bottom plate off. And on this one, I cut a 5/16 of an inch groove. This is 5/16 by 5/16, and I've got a rectangle here for the brush to go inside it. The magnets are now inside the brush, which really doesn't make a difference at all. But there is one thing to note with this groove for the brush. I want to make it as difficult as possible for the dust to leave this center area. So what I did is made sure that the shorter pieces are extending further than the long pieces, so that as the dust is created or chips are created in the center, they're going to have to come out and then go on a sharp angle to get out of this seam. If I was to do it the other direction, the other way, where this piece is extended further than these short pieces, then there'd be a slight gap right here, assuming that this isn't perfectly tight, and a much easier, more direct path for the chips to go out of this gap. So this extension really does matter a little bit in my opinion. All that to say, I think I'm ready to cut the brushes, install it, put the magnets in, install those, and the pins, bolt this up, and see what we got. On the top of the top plate, the magnets can be pushed in with one of these hex driver extensions, all the way down to the bottom of the counter bore. Should be pretty easy to do this. All right, so now the bottom of the magnets is resting on the bottom of the counter bore, exactly 1/4 of an inch away from the bottom surface. So that means the height of the steel pins needs to be somewhat precise, and to put these steel pins in here at a precise height, we're going to use the actual magnets. So let's get these pins started way higher than what they need to be. Now there's enough friction here that these should not move under normal operations. But if they do move, well then just a little bead of super glue should stop these from moving. So they need to be about 1/4 of an inch tall, a little bit more than that, because I'm going to use this top plate pushing the dowels down. So now the dowels are referencing off of the magnets, and I can push down to make sure that they are the correct height until both plates are flush with one another. All right, so now let's see, we got the dowels actually sticking through the bottom side just a little bit, which is fine, but I need to get something to elevate this so that, there we go. Magnets bottom out, pushing the dowels as far as they need to go. Now we have a top plate and a bottom plate at exactly the correct distance away from one another. And it locks into place. I think I want to put another magnet on each one of these. It just doesn't feel enough. Yeah, needs one more magnet. 2 is a lot better. So this is kind of interesting. These bristles are actually twice as long, and they wrap around a steel dowel to come out the other side, and then this piece of metal is just clamped over the top of it. So that's how that's made. I lost a couple bristles out of the ends after I cut it, so if you use this material, you have to come back and crimp the ends so more doesn't come out. But this should be a pretty tight fit. So I don't think epoxy or anything like that is necessary. Easy to start, but I think this will be a little bit of effort to get it fully seated. All right, let's jump ahead a little bit. The bottom plate, all the brushes are on, and the top plate, I went ahead and added this screw. So I drilled the hole for the screw first, then cut the slot, so that way the hole doesn't, the hole lines up before clamping. And I also cut these ports down just a little bit on the inside so they'll clear the spindle, and secured them to the top with some tiny screws. So this is ready to be mounted. All right, I've got the top plate secured to the spindle. This is easy on, easy off, and all of this, getting these small hoses with little wiggle room all connected, was testing my patience. A lot of frustration there, but it's all hooked up. I don't know how I'm gonna secure this just yet, so a bungee is the temporary solution. I don't wanna put much stress on this drag chain. So we're just gonna kinda, go with the flow and see what happens. Now to hook up the large pipe, or large hose rather, and go from there. Oh, but to do this, because the dust collection hose is coming in from the front side of the machine, the main drop, I need to put this as far away as possible to know how short to cut the hose. So all this needs to go in the back left corner before I go any further. Okay, so the dust collection is pretty much done. I've got to find a more elegant solution to hold this piece up against the spindle area. I'm using 2 bungee cords right now, and it works, but it's not the it's not the most elegant thing in the world. The magnetic shoe is working. I've actually already used this to cut a few things and to test everything out. Everything works fine. The extra 6-inch hose that we have doesn't get in the way of anything. So I have it off to the right-hand side where it drops down from the ceiling so that it could go anywhere inside the cutting area and not basically twist the hose around the spindle as it's up or down. But I've cut a few things and the dust collection works really, really well. So why did I go with 2 4-inch hoses, ports, rather than just the typical 1 4-inch that you see on a CNC machine? Well, because I have a 6-inch drop right above the CNC machine, 6-inch branch coming over here, and I've got the capacity to run 2 4-inch hoses on it. This is the only thing on this side of the shop, so I might as well use both 4-inch hoses, that much capacity. So that's why I went with that. And not only that, but more dust collection is never a bad thing. I absolutely hate dust, and this thing sucks, which is really good. So if you are interested in this particular design, go to my website. I'll have a link in the description if you're watching this on YouTube, and I'll have a free download for all of these vector files, as well as a VCarve file that I used to export my own G-code. Also, if you're interested in a single 4-inch dust collection port, you don't necessarily have to, or dust collection shoe, you don't necessarily have to purchase one. Now, there's some readily available ones that you can purchase, but you can make your own and save a ton of money. Go to the Avid website, Avid CNC, which is cncrouterparts.com if I'm not mistaken. I'll have a link down below to their dust shoe on their website. If you search in their search bar for dust or dust shoe, scroll to the bottom, you'll be able to find it. It's a free tutorial on how to make your own out of HDPE. I believe that's the material. They also have all of the shopping lists that you need. But whether or not you want to use HDPE or some plywood and ports like this, you can download their free files, and that's a fantastic starting point. That's what I used to start mine, and then I just modified here and there to fit it to my exact needs. I think that's it. Next up in this series is going to be the spoil board, which once again, I'm waiting on shipping delays. So whenever that comes, I'll get to that aspect of the build. And after that, the CNC will be 100% ready for furniture, which I'm so excited about. The spoil board is going to be really interesting with both T-track as well as some 20mm dogs for repeat locating and be able to batch out a lot of stuff really quick and easily. I'll have a vertical table as well. I'm just really looking forward to it. So if you want to be notified of when I publish that, go to my website, jacecustomcreations.com/newsletter, sign up for my email newsletter, and you'll be notified when the next video comes out, next article, next whatever. I'm rambling. You guys take care. Have a great day, and I'll talk to you in the next video.